Hey, chemistry students, Mr. McKee here. We are kicking off Unit 3 today with an introduction to covalent compounds. So here we go. Before we get into what covalent compounds are, we need to review a couple of items from earlier in the quarter. So you will recall that a molecule is when two or more atoms are bonded together with each other. And some examples of that would be N2, that's nitrogen gas, the very same nitrogen gas that we find in the air. 78% of our air, in fact, is made up of nitrogen. Oxygen, O2, it's an example of a molecule that's 18% of the air around us, and that's what we depend on to breathe. And O3, that's ozone. It's a famous gas we find in our upper atmosphere. And we have water and glucose, which is C6H12O6 there. Those are all examples of molecules, some well-known ones. Another term from earlier in the quarter that we need to know is a compound. And this is when we have a molecule that contains different elements. And examples of this would be H2O water, which you'll notice is also a molecule. And in fact, all of these are molecules. So all compounds are molecules, but not all molecules are compounds, is how we say that. CH4 is another example here. That's methane. So what I just said there can be a little bit confusing. So we have a Venn diagram to look at here. And we see that O2, N2, and O3 are just molecules over here. But these other three, H2O, water, glucose, and methane, these are both molecules and compounds, so they go in the middle there. There is nothing that's just a compound. Anything that is a compound is also going to be a molecule, so that's why this part of the Venn diagram is empty. Okay, so that's just a little bit of review. Next, we need to define what a covalent compound is. It's a compound that contains two nonmetals. So let's take a look at the periodic table here to learn what the nonmetals are. So on the periodic table, all of these elements that are red are metals, and all of the blue ones are nonmetals. Pretty simple. And then we have some that are in between, we call metalloids. Those can kind of go in either direction. Sometimes they behave like metals, sometimes they behave like nonmetals. Okay, so when we have a covalent compound, we have two of these nonmetals bonding together. All right. Some examples of that. Examples that came up earlier, at least with methane, CH4, which is methane, aka natural gas, and carbon dioxide, another famous covalent compound, which is a compound between carbon and oxygen. And those are covalent compounds because they each have nonmetals bonded together. So this begs the question, perhaps, why do atoms bond together to form covalent compounds? So for this, we're going to return to a diagram that we looked at earlier in the quarter. Hopefully you will recall this diagram where we see the Bohr models for the first 18 elements. And you may also recall from an assignment we did earlier that what atoms really want is to have full valence shells. And I guess we should review what a valence shell is. The valence shell is just the outermost electron shell for an atom. So for hydrogen and helium, which only have one electron shell, this is the valence shell. Okay. For lithium, which has two electron shells, this would be the valence shell. And for sodium, which has three, along with all the other elements in the third period, this would be the valence shell. Okay? So to go back to what I just said, You may recall that atoms are the happiest when they have a full valence shell. And when we look at these first 18 elements, only those in group 18 here have full valence shells. So these are the happiest atoms. Okay, and of course, atoms don't really have emotional states like happy or unhappy. When we say happy, we're really talking about stable. So these atoms are the most energetically stable. For that reason, they're very content. They don't want to change. And they don't tend to form compounds with other atoms. All right? The rest of these atoms we see here, though, that would be all of these, are to varying degrees unhappy. That's because they don't have full valence shells. All right? So, where does that leave us? Well, these atoms can become happy by sharing electrons with each other. Different atoms can fill their valence shells and become more happy by sharing these electrons. Okay? And we see up here that this portion of the periodic table is actually just one portion here. And as a reminder, we tend to skip these transitional elements. They're a little bit trickier. You'll cover those in advanced chemistry. Okay? So what we just said is that atoms bond together to fill their valence shells and become happier. All right? So let's consider hydrogen and carbon to understand how they do this. If we look at just the valence electrons of carbon, we see that it has 4 valence electrons. And as we established earlier, it wants 8. So by itself, carbon is unhappy. Hydrogen, we see, has only 1 valence electron. And since it has just that first electron shell, it can only hold 2, so it actually wants 2 electrons in order to have a full valence shell. So again, by itself, hydrogen is unhappy. However, together, they can complete each other. Okay, so in this diagram, we are showing how carbon and hydrogen can bond together to make CH4, which, as we said earlier, is methane. So if the red electrons are hydrogens here, then we can see how hydrogen can share its red electrons with carbon. And if the green electrons are carbon's electrons, we see how carbon can share each of its 4 electrons with these 4 hydrogens. All right. So one way we can visualize this is we can focus on one atom at a time. So if we look at this hydrogen, it has 2 electrons around it. That gives it a full valence shell. Likewise, this hydrogen has 2 electrons around it, and this one has 2 electrons around it, and this one as well. Okay, so each hydrogen is happy because it has 2 electrons around it, completing its valence shell. It doesn't matter that it's sharing those electrons, it still gets the full benefit of those electrons. Likewise, carbon, if we count up all of the electrons that it has around it, we will count 8. 2, 4, 6, 8. So carbon is now happy by sharing those electrons with 4 hydrogens. And all these atoms are happier by joining together. And that's why we have CH4 in the world, methane. So as we said, the atoms make each other happy by sharing electrons, and now they each have full valence shells. So let's summarize what we have learned here today. Nonmetals form covalent bonds in order to share electrons and fill each other's valence shells. It is that simple. So now you guys are ready to work on assignment 2 and review some of what you've just learned and learn how to name covalent compounds. Okay, have a great day, chemistry students.